All right, let's jump right in. We're going to take one of our favorite pastimes, people watching, and totally level it up. We're talking about learning how to see the world not just with your eyes, but with the trained, curious mind of a scientist.
Oh, come on. You can admit it. Most of us are, right? And for good reason. I mean, human behavior is endlessly fascinating. From a tiny little gesture to the kinds of posters someone hangs on their wall, everything is packed with information. Our everyday world is just this massive gold mine of data, if you know how to look.
But here's the thing. There's a huge difference between how we normally people watch and how a scientist does it. Our casual glance is, well, it's often biased, pretty informal, and relies on our really terrible memory. Scientific observation, though, that's the real deal. It's systematic, it's objective, and it's all built on careful, detailed records. And understanding that difference, that's the big leap we're going to make today. To get us there, I've got a 4-part field guide for you. First up, we'll cover the basics of what it means to see like a scientist. Then we'll look at how scientists cleverly sample reality, because you can't see everything at once. After that, we'll tackle the big question, to intervene or not? And finally, we'll uncover the hidden mental traps that can fool even the sharpest observers.
Okay, so let's kick things off with part 1, the science of seeing. And we're going to get right into why just looking at the world around us, it isn't going to cut it if we really want to understand what's going on.
So this right here, this is the core of it all. Scientific observation isn't passive. You're not just a fly on the wall. It's a really active process, and it's done under very specific, defined conditions. The goal isn't just to watch, it's to describe what's happening so completely, so accurately, that you build a true, unbiased picture of what's really going on.
So if observation has to be systematic, how do scientists deal with what is maybe the biggest challenge of all? You just can't observe all of a person's behavior all the time. It's impossible. Which leads us right into our second section. How in the world do scientists sample reality?
And the solution, the secret sauce, is sampling. See, instead of trying to see absolutely everything, scientists get smart about it. They strategically choose what, when, and where they're going to observe. And the whole goal is to capture a small slice of behavior that's actually representative of the much larger picture. One of the key ways they do this is with something called time sampling. This just means choosing very specific chunks of time to make your observations. Think about it. We might only ever see our boss during a stressful Monday morning meeting. That's a super biased sample. Time sampling forces us to look at all the different moments to get a much more complete and frankly more accurate picture. And scientists have some really cool tools for this. They can schedule their observations systematically, like clockwork, or they can do it totally randomly. But my favorite has to be the EAR device. That's an electronically activated recorder. It's this little gadget people wear that randomly records 30-second audio clips of their day. It gives researchers this incredible, completely unfiltered log of what daily life actually sounds like. How cool is that?
But, time is only half the puzzle. The other half is situation sampling. This is all about observing behavior in as many different places and under as many different circumstances as you possibly can. For example, some fascinating research found that the way chimpanzees make eye contact is totally different in a group in the US versus a group in Japan. Context, it turns out, changes absolutely everything.
Which brings us to our third section, and this is a really critical choice for any observer: to intervene or not. Do you just hang back and watch from the sidelines, or do you step in and actually become part of the action?
Well, an observer's toolkit is actually pretty diverse. The first big choice is whether you're going to be direct, watching behavior as it unfolds, or indirect, by looking at the evidence people leave behind. But the bigger choice, and the more interesting one, is whether to intervene. You can just watch quietly from a distance. That's called naturalistic observation. Or you can actively set the stage using some of the techniques we're about to dive into.
So let's look at this amazing example of what's called structured observation, where scientists basically create a situation. To study something called inattentional blindness, researchers had a clown, a real live clown, ride a unicycle through a busy university plaza. The big question was, who would even notice?
The result is, it's pretty staggering. I want you to really think about this. A clown on a unicycle. It's not exactly subtle. And yet, only 25% of the people who were talking on their cell phones even saw him. It's just this incredibly powerful demonstration of how our focus can literally make us blind to the world that's right there in front of us.
Now, some questions you can't answer from a distance. you have to get more extreme. To really truly understand a group, sometimes you have to become one of them, without them knowing you're there. And this has a very cool name: disguised participant observation.
And the most famous and controversial example of this is the Rosenhan study from way back in 1973. Okay, so first, a group of totally sane researchers pretended to hear voices just to get admitted to different psychiatric hospitals. Most of them were immediately diagnosed with schizophrenia. The second they got inside, they dropped the act completely and started behaving normally, just taking notes on everything they saw. And get this, even though they were perfectly sane, they were kept in the hospital for weeks, one of them for almost 2 months.
The study reached this incredibly powerful conclusion. As David Rosenham, the lead researcher, put it, once the pseudo-patients were labeled schizophrenic, they were stuck with that label. It was like a lens that colored everything they did, and the researchers were totally trapped by that diagnosis.
This whole story leads us perfectly into our final and maybe most critical section, the observer's hidden traps. Because even with the best methods in the world, every single observer faces 2 huge challenges, something called reactivity and something called bias.
Okay, first up is reactivity. This is such a fundamental problem in psychology. It's the simple fact that the very act of watching someone can change how they behave. People might try to act like good participants, or they do things they think you want them to do, which means you're no longer seeing them act naturally at all.
So how do scientists get around this? Well, they've got 3 main tricks up their sleeve. First, they can hide, basically. They can conceal the observer, like in that disguised study. Second, they can just hang around for a while and let people get used to them. It's a process called habituation. Or third, they can use those indirect methods we talked about, like studying people's garbage or public records, where there's just no way for reactivity to happen.
Now, for the second major trap, observer bias. This one's tricky because it's all about us. It's when our own expectations, our theories about what we think should happen, cause us to make systematic errors in what we actually see and record. Our beliefs can literally change what we perceive.
Let's go right back to that psychiatric hospital study for a second. The researchers inside, they were constantly taking notes. Now, a staff member who was expecting to see signs of mental illness didn't see a researcher doing their job. They saw a patient's obsessive writing behavior. That is a perfect and kind of chilling example of observer bias out there in the real world. So what's the fix? How do you fight your own brain? Well, first, just knowing that bias is a thing is a huge first step. Using automated recording equipment helps take the human element out of it, but really the gold standard method is to keep the observers blind. If the person recording the data has no idea what the study is trying to prove, their expectations just can't get in the way and contaminate the results. And all of that leaves us with one last question, a question for you. We've just walked through how scientists try to see the world objectively, by sampling reality, choosing when to intervene, and fighting their own biases. So now that you know how they see, what expectations, what hidden traps might be shaping what you see every single day?